rational operations. And rational operations is one of the first applications of factoring. So we just finished our unit on factoring, and a lot of the things that we're going to use factoring for, one of the primary skills we use factoring for, as we kind of talked about through the factoring lessons, is to solve higher order equations. If we want to solve, find all 6 zeros of a 6th degree polynomial equation, if we can factor that 6th degree polynomial into linear factors, then we could find the 6 solutions. Or if we could get it into quadratic pieces, then we could use the quadratic formula to find it. So that's where we're heading, and that's one of the primary skills of factoring. But another very important skill another very important thing that we use the factoring skill for is evaluating rational expressions, simplifying rational expressions, doing rational operations, solving rational equations, and graphing rational functions. Okay, I use the word rational there a lot, right? Rational expressions, rational equations, rational functions. Factoring will be involved in all of those things, and those are all things that we're getting to the road. So what do we need to know here? What do we mean by rational operation or a rational expression? What does rational mean in math? What do we mean by rational expression? What do we mean by rational number? Somebody that could do the cricket sound, it would be perfect time for it.
Is it just like a real number?
Well, rational numbers are real numbers. The real numbers are made up of rational numbers and irrational numbers. What are the rational numbers?
Are they the ones without the square root?
Well, some square roots are rational, but some square roots are irrational. Like the square root of 7 is irrational. The square root of 4 is rational because it's a integer actually. Rational numbers are numbers that can be written as a ratio of 2 integers. Okay, so when we're talking about rational expressions, we're talking about fractional expressions. Algebraic expressions that are written in fractional form. Okay, so what we're going to be doing in this lesson, this unit that we're going to carry over the next probably 3 or 4 days, is adding, subtracting, multiplying, dividing rational expressions. Okay, more specifically, algebraic rational expressions, fractions that have algebraic expressions in the numerator and/or the denominator. Okay, so here's an example of what we'll be doing. Simplify, and this is just, we're simplifying a fraction here, x squared minus 3x minus 4 divided by x squared minus 1. We're simplifying. Okay, we're simplifying a fraction. Alex, how do you simplify a fraction?
Try and get everything to the numerator.
We could divide the denominator into the numerator. Is that what you're saying? Try to get it all into the numerator. Is that what you mean by that? Yeah. How would we simplify? Let's go back to some of our, childhood mathematics. That's a rational expression, right? It's not an algebraic rational expression because it doesn't have variables. But how would you simplify 8 over 12? Everybody knows what it is, right? What would this be simplified? 2/3, right? You can do that, but if you've done it so many times, you don't really know what we're doing, right? How do we get 8/12 to be 2/3? Well, yes and no. Okay, that's the way we've ended up doing it. We're taking out a factor of 4 from each one. So we can write 8 as 4 times 2, and we can write 12 as 4 times 3. And once we have the number in that factored form, what is 4 divided by 4? Those cancel each other out, and we're left with 2/3. So the process of simplifying fractions, and this has been so long ago since you saw it that way, you're just used to dividing the top and bottom by the same thing. But that concept doesn't work with here. X squared minus 3x minus 4 times x squared plus 1. if I told you we're just going to divide the top and bottom by x plus 1, it just doesn't compute, right? So the way you simplify a rational expression is by canceling common factors between the numerator and denominator. Common factors, right? Can't cancel terms. We can only cancel things that are being multiplied. I couldn't divide 8 and 12 up into 4 plus 4 and 4 plus 8 and cancel the 4's, right? That doesn't work. It has to be things that are being multiplied in order for us to have the equivalents hanging around. So we can't cancel things that are being added or subtracted, only things that are being multiplied. Okay, so we need to factor each of these expressions, and if there's anything that they have in common, common factors, then we can cancel it, right? What is the factorization of x squared minus 3x minus 4?
X plus 1, x minus 4.
X plus 1 times x minus 4 is correct, right? Now what is the factorization of x squared minus 1?
X minus 1, x minus 1.
X plus 1, x minus 1, right? It's okay. You know, don't fight over it now. It's okay, Jagger. You can't be scared of a man in a pink cast anyway, though.
I don't know, this thing
Pink
hurts.
cast is hard. Doesn't even.
Do what?
Pink cast is pretty hard.
It is pretty hard. That's true. All right. Now, what do we notice here?
You got the same term on top and bottom.
It's not a term. It's a
Oh,
it's a factor, right? We have the same factor top and bottom, x plus 1 that we can cancel out, and then we have as a final answer here, we have x minus 4 over x minus 1. Correct? Now, here's the $1,000,000 question of the day. Here's what's going to stretch you and make you think a little bit. Okay, what we're saying is that this expression that we started with is equal to this expression right there, right? Just like 8 over 12 was equal to 2 over 3. Or is it? This is certainly always true. But is this top expression always equal to x minus 4 over x minus 1? Now you're saying no because I'm kind of, my questioning is, I wouldn't be asking that question if the answer was yes, right? Can you tell me when it's not equal to it? When are these two expressions not equal? When is this thing up top not equal to that?
After you cancel out the x.
It has something to do with what we canceled out, absolutely, right? When we canceled out the x plus 1, we changed the value sometimes. Right? No? Not getting it? Jagger, you said they're not always equal. Can you tell me when they're not always equal?
I don't know.
Let's take this expression right here. Y'all watching? And let's evaluate it for x equals negative 1. So I would have negative 1 squared minus 3 times negative 1 minus 4 over negative 1 squared minus 1. What does that give me up top? What?
Or no, 4.
Gives us 0, right? Positive 1 plus 3. We got positive 1 plus 3.
Oh, darn.
That's 4. 4 minus 4 is 0, right? And in the bottom, I got positive 1 minus 1, which is 0. What is 0 divided by 0? You can't do it, right? It's undefined. It's no good. It's broken. Right? So, but can I take this expression and evaluate it at x equals negative 1? What do I get? I get negative 1 minus 4 over negative 1 minus 1. That's negative 5 over negative 2. That's 2.5. All right, so I've just shown you that this original expression and this bottom expression are not equal to each other if x is negative 1. Now we could take any other value of x and those two things would be equal. Put 0 in the top expression, what do you get? Negative 4 over negative 1. Put 0 in the bottom expression, what do you get? Negative 4 over negative 1. They're equal at 0. They would be equal at any other number for x that we plug into the expression except for x equals negative 1. Now, where does that negative 1 come from?
It's a factor.
It's the what?
It's a factor.
It comes from this factor right here, doesn't it? X plus 1 is equal to 0 when x equals negative 1. So this is the bad part. X plus 1 is bad at negative 1, and we took it out of the way. So here's how I'm going to want you to write your answers for these problems. This thing is indeed equal to this thing as long as x is not equal to negative 1. This is called the excluded value for the excluded. Yeah, whatever. Laugh it up. Excluded value. It makes you think a little bit, right? What does this x equals negative 1? Why do we have to have this here? X can't be negative 1. Because if x equals negative 1, this thing is not equal to this thing. All right? Now, some textbooks, and even our books on these problems, have x cannot equal negative 1 or positive 1. Why would they put positive 1? X can't be positive 1. So what happens right here if we put positive 1? We'll get a 0 in the denominator, and that's very, very bad, right? But my argument, and I like my argument, if I put 1 in that first one, it's very, very bad also, right? It falls apart. Now, the positive 1 is significant because it does break this piece of things. It breaks this piece also, though. So my argument is, because we're just simplifying an expression, we only need to exclude the negative 1, because the negative 1 is the only value that makes this thing different from that thing. Okay? 1 breaks them both. They're both equally awful if x is 1, but only one of them is awful if x is negative 1. So we have to exclude the negative 1 in order to use this equal sign right there. Okay? Now, when we do rational functions, when we're graphing rational functions and we're solving rational equations, this line of thinking is going to come into play. The negative 1 and the positive 1 are going to be important when we're graphing rational functions. The negative 1 is one type of bad spot. The positive 1 is another type of bad spot. One is an asymptote. The other one is a hole in the graph. Okay, so we'll have to know the difference when we get to that point. But I want you to kind of be used to dealing with these excluded values before we get there. All right? Now, let's have a look at this one. X squared plus 6x plus 8 divided by x cubed plus 8. X squared plus 6x plus 8 divided by x cubed plus 8. We're just going to simplify this fraction. We're looking to reduce it. Okay, and we said at the beginning of the lesson that the only way we can reduce a fraction is to cancel common what? Factors. Okay? So I need to cancel common factors. I have to find the common factors, and I do that by factoring. Right? What's the factorization of the numerator? X plus 4 times x plus 2. Correct, Jagger. Now, what is the bottom? It's 2 terms, right? How do you factor 2 terms? GCF, difference of squares, cubes, right? So this takes us into some different factoring, right? So what is the factorization of x cubed plus 8? X plus 2 times x squared minus 2x plus 4. Right? Javen? See your mistake there?
Yeah, I said multiple on them.
Yeah.
You have to
Yeah, now we can simplify, right? X squared plus, so what will cancel here?
X plus 2.
The x plus 2's are going to cancel, right? And as soon as we cancel that, we're making a very, very big change in the function, right? We're removing something that's really bad from the numerator and denominator. If we're removing a 0 over 0 there, we're changing the value of the thing. So our excluded value is going to come from that point. Well, we're left with x plus 4 over x squared minus 2x plus 4. And this thing that we started with is equal to this as long as x is not equal to what? Negative 2. Because again, if x equals negative 2, if I put negative 2 in up here, I get 0 over 0. If I put negative 2 in there, I do not get 0 over 0. I'll get a perfectly good number. Okay, so I have to qualify this equal sign by excluding this value for x. Peyton.
So if we're taking a quiz, do we have to put that beside the answer?
All right, the way I'm going to quiz you on this, because it's really, really easy to forget, is I'm going to have a blank for the answer, and I'm going to have a separate blank where I ask you to tell me the excluded values. I'm going to remind you to include those parts of your answer. Now, we're good. Is everybody okay with that? Now, let me go back and remind you of one thing here, because this is going to be helpful to us. No, I'll do it on the next example. Ready? We're going to do one more and then we're going to quit for the day. Short day. Okay? On the next example, I want to make the point that I was about to make there. No, it's the one after this. Was it the next one? I'll give me a second. Yeah, it was that one. Maybe I'll make the point tomorrow because we're still going to stop on this one. Try this one on your own. Okay, so we're good. What do we get when we factor x squared plus 8x plus 12?
X plus 6.
X plus 6 times
X plus 2.
x plus 2. All right. What about the next term there? 3x minus 6. What's that going to be?
3 times x minus 2.
I'm not sure that's what's next on the PowerPoint. X squared minus 4 is x plus 2 times x minus 2. 3x minus 6 is 3 times x minus 2.
Oh, my gosh.
Yeah. I thought I heard you say a 3 there. Yep. And then x squared plus 7x plus 6 will factor as x plus 6 times x plus 1. Now, we've got a lot of things that will cancel here, don't we? And what does that mean? It means we're going to have more excluded values, right? Every time we cancel something, then we're making a pretty significant change. Even though the value of it is 1, at one point of the function, when we look at the graphs of these things, you're going to see how big an impact these little things have that we're canceling here. So we can cancel the x minus 2's, the x plus 6's, and the x plus 2's, and now we're told that this is equal to 3 over x plus 1, as long as what? What are our excluded values here? X cannot be
Negative 2.
negative 6, and positive 2. So let's write that as positive or negative 2 or negative 6. Would it be okay to go ahead and exclude negative 1 also? You can. It's just in a different category of excluded. Okay? And here's what I mean by that. If we were graphing this function, if this was a function, if y was equal to this thing, y, we simplified it to be that, these three things are holes in the graph. Negative 1 is an asymptote in the graph. Okay? And so that's a big, huge difference. It's a completely different kind of discontinuity. Negative 1 breaks the function but it breaks it in a different way than these three values do. So I want you to always be able to see the distinction between the values. Okay, the bad values, called points of discontinuity. The function's broken in those points. All right. Okay. Now we'll pick up here tomorrow, and